In this tutorial, I'm going to show you how to use the Analog Discovery's voltage instrument. The voltage instrument can be used to apply fixed voltages to your circuits, either positive or negative 5 volts relative to ground. The voltage instrument is pretty simple. We can really only turn it on or off, so it won't take long to show you how it works. Since the voltage instrument is so easy to use, I'll spend the latter part of this video demonstrating how to create a simple circuit which lights up a light-emitting diode. In the process of implementing this circuit, we'll also talk briefly about solderless breadboards, resistors, and light-emitting diodes. If you're already familiar with these components, you won't get much new information, so you can skip that part. In this video, I'll assume that you've already downloaded and installed the waveform software on your computer, that you have properly connected the Analog Discovery to your computer, and that you can open the waveform software. If you need some help getting set up, the first Quickstart video covers these topics. This is a representation of the orientation of the connector pins on your Analog Discovery. The voltage instrument controls the terminals labeled as V+ and V-. The voltages applied by the voltage instrument are all relative to a reference voltage set within the Analog Discovery. This reference voltage is generally called ground, and it is denoted by a downward pointing arrow. The electrical circuit you're testing using your Analog Discovery will typically need to know what this reference voltage is. Access to this reference voltage is provided by the Analog Discovery at these 4 terminals here. On the Analog Discovery, V+ is connected to a red wire, V- is connected to a white wire, and all 4 ground terminals are connected to black wires. To open the voltage instrument, simply click on the voltage icon on the waveform's main window. The voltage instrument is very simple. You're simply allowed to turn the constant voltage supplies, V+ and V- on or off. The voltage supplies can be controlled independently by using the 2 lower buttons. Clicking on these buttons toggles the state of the voltage supplies between off and ready. These buttons themselves, however, do not actually turn the power on or off. When you're satisfied that you have enabled the correct power supplies, click on the main power button to actually apply power. Once you turn the main power button on, the power supplies denoted as ready turn on, and the power supplies denoted as off remain off. I want to re-emphasize here that these voltage supplies are not adjustable. V+ provides positive 5 volts relative to ground, while V- provides negative 5 volts relative to ground. These voltage levels cannot be adjusted. If you need voltage levels other than these 2, you need to use the WaveGen instrument. We'll present that instrument in a separate video. That's really all there is to the voltage instrument. As I mentioned before, I'll now show you how to create a simple circuit and power it using the Analog Discovery. If you're somewhat familiar with light-emitting diodes, resistors, and solderless breadboards, you may want to skip this part of the video. If you're new to creating electrical circuits, the next part of the video will give you a chance to implement a circuit which seems to do something. It will turn on a light when the voltage instrument is turned on. This is the circuit symbol for a light-emitting diode. The term light-emitting diode is often abbreviated as LED. The LED has 2 terminals, an anode and a cathode. You can tell them apart by the length of the wires used to connect to the terminals. The anode's wire will be longer than the cathode's. An LED lights up when the voltage difference, VD, is greater than about 2 volts. This is a red LED. The anode here has a longer wire than the cathode. When we wire this into our electrical circuits, we'll need the anode to be at the higher voltage of the 2. LEDs will burn out if the current through them is too large. We can limit the amount of current passing through an LED by adding a resistor to the circuit. The overall circuit we're going to use is shown here. Here's the resistor we're going to use. Resistor values are indicated on these small resistors by color bands. The 100 ohm resistor has stripes in this order: brown, black, brown. Now we need to apply 5 volts to our circuit. We can do this with the Analog Discovery's voltage instrument. If we use V+ to apply the voltage, we'll put ground down here. Now we just need to show how to interconnect these components to create our overall circuit. There are a number of methods for interconnecting circuit components. We'll use a solderless breadboard to implement our circuits. A solderless breadboard is a white plastic component with rows of holes in it. The holes in the breadboard are in a particular pattern. They're organized in rows, each row containing 5 holes. There's a central channel running down the middle of the breadboard, separating the 2 rows. Any row is electrically isolated from any other row, and all the holes in a given row are electrically connected. So, inserting leads from 2 components into the same row connects those components. To implement our circuit, let's connect the diode's anode to one terminal of our resistor. Now we can apply power to the other terminal of the resistor and ground to the cathode of the diode. Our circuit's complete, so to make our diode light up, we just need to turn on the power. To do this, open the voltage instrument, if it isn't already open, enable V+, and turn on power.